This video is a supplement to activity 4.7, which is cams in motion. So at this point we should have a fully assembled and operational automata box. And you can see actually on here I've actually turned off some of my constraints. I'm only focusing on the pair cam in this example. So when I turn the handle, you'll notice that the pair cam will move, or the follower will follow the pair cam. Alright, but the idea behind this activity is that we're going to study the motion that's created by the cam. And so in doing this, we're going to create actually two motion graphs on the same cam using different nominal diameters. And so if you remember, the first nominal diameter that we used was 1.5 inches. That's from the drawing sheets. And then so we'll create our motion graph based on a nominal diameter of 1.5, and then later on we're going to go through the exact same process with a different nominal diameter, and then we're going to create a mathematical model which will help us make some predictions later on down the line when it comes time to create a custom automata. So, alright, so what I wanted to do is just kind of model some of the things that we're going to do in this activity so that you can see what's going on. So, first thing I'm going to look at here is this particular table. So we're going to collect some data in order to create our motion graph. And so basically what we're going to do is we're going to look at starting at 0 degrees, and every 30-degree interval we're going to record some specific information that's going to help us draw our motion graph. So the information that we want is what is the height of the top of the follower from the center line of the shaft. So that central axis going along the length of the shaft all the way up to the top of the follower. What is it at 0 degrees? What is it, at 60 degrees, so on and so forth. It'll be able to give us an idea of what that motion looks like over the course of one rotation. Then we're going to do the same thing, but we're going to look at it from the bottom of the follower, so which will be pretty easy for us to do. So, alright, let's go back to Inventor, and we're going to take a look at how we're going to find that information. Okay, so in order to find this information, we're going to have to do a couple things. So the first thing I want to do is actually move my handle down, and basically what I'm looking to do is I'm looking to get the pair cam to be facing down. I just want it to face down so that this follower is at its lowest point on the pair cam, which is good right now. And we're going to create a new constraint here, something that we have not done before. So we're going to click on Constrain. We're going to use what's called an angle constraint. So we'll click on that, and we're going to use what's called a directed angle. The directed angle basically says I want two surfaces to be sitting at the same angle, or maybe a certain angle to each other. So in this case, our angle right now is set to 0 degrees, which means that these two surfaces would be parallel. So it's asking for surface number 1, which I'm going to choose a vertical surface, which is this one here. And then I want this surface to be at 0 degrees to the side of the box. So we'll go there. Okay, and so now you'll see that the surfaces are parallel. We're sitting at 0 degrees. We'll go ahead and hit apply there. Once we've done that, you'll notice that we can no longer turn this because we now have a constraint that's preventing that from happening. So while that is constrained, we're going to use Inspect Measure, and I'm going to click on the shaft, and then we're going to click on the very top of the pair cam follower. And so you'll see that at this point, from the shaft to the top of the pair cam follower is, in my particular model, 4.75 inches. So I've copied the table over to Excel, and you can see I have an interval of 30 degrees all the way to 360. And it says here, what is the height of the top of the follower? So we said 4.75 is what I believe it was. Yep. and it says what is the length of the follower. Well, I know that my follower is 3.5 inches long, and that's actually not going to change, so we're going to just copy that across there. And then we're going to create a little formula here. So if the top of the follower is at 4.75, the bottom of the follower is just going to be this value minus the length of the follower. So we'll create a formula by putting in equals, and then I'm going to choose this cell, B6, minus this cell. And then so I should have equals B6 minus B8. We'll hit enter, and then I can use this little square to copy that formula all the way down across the 360. And so now those will automatically populate. You'll see this one is B6 minus B8, the next one is C6 minus C8, and so on and so forth. So now what we just have to do is edit that angle and figure out our distances all the way across. Alright, so we're going to go back here to Inventor. We're going to click on the, we could use the bracket here, or we could use this sidewall. Either way, we'll just click on this. You'll see that it highlights here, and then you'll see that there is our angle constraint. So we're going to want to edit that. So I'll double click, we'll put it at 30 degrees, hit enter. You'll see that that moves it 30 degrees, and now we can again, sorry about that. Now we can again figure out our distance. So we'll hit M, we'll choose the shaft, okay, and then we're going to say to there is 4.75 again, right? Pretty shocking. Okay, so we're going to put that information into there, and we're going to continue this pattern all the way through. But what you may run into is, I'm not going to go through all of these with you, but let's say we do something like 120 degrees. Okay, in this case it worked. In some cases it might not, or maybe we get, say, 210 degrees. Alright, it actually is working just fine with mine, but in some situations you may get an error. You may say, oh, it can't rotate to that particular degree based on, you know, your cam shape or something like that, and that's okay. What you can do to solve that is, let's say you're trying to go to 120 degrees and it throws an error. Okay, so what we'll do then is we will click on the follower, and you'll see that the follower gets highlighted. It's follower number 3, and what we'll do is we will actually delete the transitional constraint so that now it can leave the cam. And then we'll set our angle to the desired angle. So we'll go back up, we'll change our angle to 100, I'm going to go to 150 this time. Okay, and then what I'll do is I'll just reapply the transitional constraint. And then once we reapply that constraint, then we'll do our measurement. So we'll say, okay, we'll measure from the shaft to the top of the follower. So 4.865 is going to be my distance at 150 degrees. So we're going to continue that all the way through, and in the next video we'll look at how we turn this data into a motion graph in Excel.